Hello and welcome to today's class. Today we have an interesting topic to discuss on standard electrode potential. Now, this standard electrode potential is a subtopic under electrolysis, and I believe by now you must have watched the introduction to electrolysis. If you have not, kindly get to the video before this to watch the standard electrode, to watch the electrolysis. Okay, so let's move over to standard electrode potential. Now, we'll be looking at the basic concept and basic definition of the concept under standard electrode potential. And this include one, standard electrode potential. What is it? It is the measure of the tendency of a half cell to gain or lose electrons. A half cell to gain or lose electrons when compared to standard hydrogen electrode, which has a defined potential of 0.00 volts. So, standard electrode potential is just measuring, you are comparing this cell versus the reference cell. The reference cell is the standard hydrogen electrode. So, you are comparing whatever you have here with this as a reference. The She is standard hydrogen electrode. That's what we refer to as what? Standard electrode potential. Now, what is electrode potential? It is when a metal is placed in a solution containing its own ions. A potential difference is established between the metal and the solution. So, when you place a metal in a solution containing its own ions, say zinc, you place it in a zinc electrode, a potential difference is going to be established between the metal and the solution. Say zinc, you place zinc in zinc tetrasulfate 6 solution. A potential difference is going to be established between the metal and the solution. Now, what is standard hydrogen electrode, She? It is actually a reference, like I said before. It is a reference electrode which is set at this volt, 0.00 volts, under standard conditions. It's just a reference point. It's just like your four-figure table you are looking at. Okay, this is this, okay. So it's just a reference point you look at to measure whatever you have, or to compare whatever you have. It's just a reference point to compare whatever you have. Now, what is standard conditions? What are the standard conditions for this standard hydrogen electrode? The standard conditions are: 1. Temperature must be at 25 degrees Celsius or 298. You add 273 to this, it gives you this. Then 2, concentration of the ions must be 1 mole per liter. 1 mole per liter. And then the pressure must be what? 1 atm. So these are the standard electrode potential conditions. The standard hydrogen electrode. These are the standard conditions for standard hydrogen electrodes. Now let's also look at more concepts and how to interpret these values. So, looking at this question, which one will be the cathode and which one will be the anode? This zinc and this copper. Zinc higher than this copper in the electrochemical series is going to be the what? Anode. Remember, anode is positive electrode. So between this and this, who is positive electrode? This. Even though the values are not talking about electrodes. The values are just talking about oxidation and reduction. So the more electropositive an element is, the more anodic it will be. And the less electropositive, the more cathodic it will be. Are we following? So at the anode, you have your zinc. At the cathode, you have your copper. So using the values here, so this is cathode and this is anode. So cathode, electrode potential of cathode, this is cathode, plus 0.34 minus, this is anode, minus. Now remember, please be careful, because some students, they will just put minus and then they will not write this minus again and you will fail it. So be careful about this. So minus 0.76. So you have that plus 0.34 plus times plus will give us minus 76. So you add up plus 0.34 plus this plus this, 10. This plus this, 10 plus 1, 11. This plus this, 1 volt. Answer. You put your plus. Are we together? Okay, so let's learn how to interpret standard electrode potential. Now, positive electrode values, positive standard electrode values, these are electrodes good at gaining electrons. Now, the positive standard electrode potential values are those electrodes that are good at gaining electrons. For example, copper. Copper is good at gaining electrons. So you have that copper is, the standard electrode potential of copper is plus 0.34 volts. Please, you must be very careful with the signs. The signs are very important because the signs tells us something about that electrode. So this positive here means that it is good at gaining electrons. In other words, reduction takes place there. Are we together? All right. Negative electrode values. These are electrodes that are good at what? Losing electrons. So those ones that are good at losing electrons, as you can see, they come with what? Minus. So simply say, let me just make this in very simple. You remember the electrochemical series I gave us? If you could remember, if I gave something like zinc and say tin, zinc comes before tin. So between zinc and tin, who is higher in electrochemical series? Zinc. Are we together? So zinc, if this and this are to be in the same cell and you're asked to find the EMF, you will discover that this zinc, being higher in electrochemical series, will tend to lose electron faster than this. So this will give you a negative value and this will gain, giving you what? A positive value. Are we together? So that's basically what this is talking about. Now, the more positive the standard electrode potential, the greater the tendency for reduction to occur. The more positive a standard electrode potential, the greater the tendency for reduction to occur, and vice versa. In other words, the more negative the electrode potential, the greater the tendency for oxidation to occur. Are we together? Good. So those of them higher in electrochemical series, they tend to easily lose electrons, therefore forming negative. But while those of them lower in electrochemical series, they tend to gain, thereby forming positive. I believe these values are well interpreted. Okay, now let's look at a zinc-copper cell. A zinc-copper cell, remember, zinc and copper. Zinc is higher than copper in the electrochemical series. So zinc is going to lose easily and copper is going to do what? Gain. Are we together? So at the anode, remember, this person that is going to lose is the anode and this person that is going to gain is the cathode. So at the anode, what will happen is that zinc will lose electron. And then at the cathode, cathodic reduction, anodic oxidation, at the cathode, this copper will gain electrons to be deposited copper. Now, if you're asked to calculate the EMF of this cell or the standard electrode potential of this cell, how would you do that? Very simple. Using this formula, E cell or EMF is equals to E cathode minus E anode. E cathode minus E anode. Are we together? Okay. Now, looking at this question, which one is the cathode? Remember to put your plus or your minus. Are we together? So the answer, the EMF of this cell is 1.10 volts. Isn't it simple? Let's solve one more. Okay, so look at this question. You are asked to calculate the EMF of the cell or the standard electrode potential of the cell. So how are you going to do that? Using the formula, EMF or E cell is equals to standard electrode potential of the cathode minus standard electrode potential of the anode. Now, looking at these two, which one is the anode and which one is the cathode? Who is higher in electrochemical series here? This person is higher, so this is the anode. Then the lesser one is the what? Cathode. Are we together? So the cathode is this, using the formula. Remember, it's plus, minus. Then the anode is this. This is another minus. Please be careful of this second minus, because that's where many students fail this question. So minus times minus is going to give us what? Plus. So we are going to add up. This plus this, 6. This plus this, 12. This plus this, 3. So our E cell or EMF is what? 3.26 volts. Isn't it simple? So please remember, you must know your electrochemical series very well. Know it offhand, so that you'll be able to know which is higher than which in the electrochemical series. The higher one will serve as the anode, and the lower one will serve as the cathode. You can easily now solve using the formula. All right. Thank you very much for watching. We've come to the end of today's class. So quickly move to the next video on laws of electrolysis, including the calculations. Quickly rushing now. Okay. Thank you for watching. Do well to subscribe to our channel and also invite your friends to do so. Thank you and bye.